What happens is you get more money if you actually pick the right order, okay? Now, what if I said this? I'm going to start with Adam. I'm going to give Adam 500, Angeliki 500, Paul 500, John 500. Does it matter when you get what seat you're in?
No.
That's a combination. A combination is when the order is not important, okay? There's sometimes, like for instance, I'm trying to think, with the lottery, that as long as you pick the numbers and they get picked, that's fine. But sometimes the order in which they're picked, okay? How many of you guys have ever done horse racing before? Okay, well you guys are all humane. I do the electronic horse. Oh, you did?
Like really young.
Oh, okay, so you didn't know any better that the horses were being beaten, malnourished and all that stuff. That's okay, we eat them when we go to McDonald's anyway. I know, true stories. Regardless though, there are some times when it's a combination to where you just pick the first three, okay? And then when you pick that's something called a trifecta, and there's something called an exacta to where you pick them in the exact order in which they come in. That's a permutation. So a trifecta is a combination, an exact is a permutation, okay? So I'm just trying to give you guys some real life examples as to the difference as to where combinations and permutations occur.
And it's all gambling.
No, you're absolutely right. Probability and statistics is heavy in gambling and that sort of thing, okay? And you guys are probably, like, how many of you guys have ever watched on TV, like at 3 in the morning, they have the poker tournaments on there?
Oh, yeah.
And sometimes you hear, oh, this guy has a doctorate in mathematics. And you're thinking, why is that guy doing poker? Well, guess what poker is?
Yeah.
Permutations and combinations. That's all poker is. It's just random probability of things occurring based upon what you think the other person might have. That's all it is. So if you know your combinations and permutations really well, you have a good chance of beating somebody else. Because remember, you're only playing against another person when you're playing poker, okay? That's why some of these people that go to like poker tournaments, they have no idea what they're doing. They just really quickly lose money because they're not betting against the probabilities. They're just betting on what they feel, okay? And it's great to feel something, but it's even better to know what you're betting for. So anyway, so let's go ahead and talk about like maybe some of the formulas that are arranged with these, okay? So like we said, permutation, the order is important, combination order is not important, okay? These are the formulas for being able to utilize permutations and combinations, okay? So the number of permutations, if I have n elements and I select r of those, okay, would be this formula right here, n factorial over n minus r factorial. So let's say for some reason, okay, I had 4 elements and I wanted to pick 2. Then n would be 4 and r would be 2. That's how many permutations I could get out of that. The number of combinations, so whenever we see this format, this is combination, and the only difference in the formulas is that there's an r factorial in the denominator. Okay? All right, so I want to show you guys some applications of combinations and permutations. Okay, again, these are fairly easy. They're a little bit more tedious than the previous, but they're not that difficult. Okay, so let's say for some reason we're considering the word ownership. Okay, I want to answer the following. Okay, so how many ways can the word be arranged to create new words? And when I say words, I just mean arrangements. It doesn't actually have to mean anything. Okay, how many ways can the word be arranged to create new words if the first letter must be E and the last must be R? How many letters how many 5-letter words can be created from ownership? How many 6-letter words can be created if the first letter must be F? Okay, there's actually 2 different ways to do these problems. So I'm going to show you guys both ways to try to tackle these. Before I answer any questions for you guys about this, let me ask you guys a question, okay? What do you guys think? Is this a combination or a permutation problem?
This is a combination.
This is a permutation problem. How many letters are repeated in the word ownership?
None.
None. They are all unique and distinct letters. That means the order is important for every single letter, right? Okay. So this is a permutation because they're all unique letters. Okay, no repetition, right guys? So anytime you guys have elements that are completely unique, that's generally a permutation as to how we arrange it. Does that make sense, guys? We're going to see examples later where there is repetition and we can use a combination.
So you're saying the word ownership is a permutation, but when we do say the letter A there, then the order doesn't matter.
Oh no, it does. Like if I flip the O and the W around, I get a new unique word out of that, right?
Well, each answer
Correct.
is going to be a permutation.
Right. Each answer itself is a permutation, right? Because they're all going to be unique. There's no repetition. You're never going to get a repeated word if you flip any of the letters around, right guys? So that's a permutation. So, my first question is, how many ways can the word be arranged to create new words? There's a few ways you could do this, okay? One of which is, since there are how many letters? 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Couldn't we do this? 5, 6, 7, 8, 9. Okay. How many ways are there to pick the first letter? 9. Second? 8. Third? 6, 5, 4, 3, 2, 1. That's one way to set up this problem. Or in other words, what's that the same as, guys?
Factorial.
9 factorial. By the way, in your calculator, you guys may or may not know, but there are some functions to help with factorials and combinations and permutations. Let me bring that up so that way everyone knows how to do that. In your calculator, you can just do 9 math, and then you go over to you go over to prob. And then the factorial button is the fourth one down. Okay, so that's one way to do this. And then you get this horrible number of 362880. What's another way that we could do the exact same problem, maybe using a permutation instead? Well, permutation. How many letters do we have?
9.
How many are we selecting?
1.
Nope.
9.
All 9, right? We're trying to create all new words from that. Let's see if this gives us the exact same thing if we were to substitute it back in. Okay, so let me show you guys how to use the calculator to evaluate a permutation. Okay, you would type in the first number, which is 9 in this case. You would hit the math button, and you would go over to prob, and then you would go down to NPR, hit enter, and then 9 again. Okay, I'll do that again so that way you guys can see everything. And even though it might be difficult to see, you guys can see that we do get the same exact number. Okay? So I don't care which way you guys do it, okay, but make sure you know one of the two ways. Okay? So just in case you didn't see that, by the way, we're going to be doing this a lot with bigger numbers, so it might be good to make sure you know how to do it. You type in the first number.
That wouldn't work with if you had two different numbers.
That's correct. We'd have or two of the same.
No, I mean if if N and R were the same.
Oh no, it would still work.
I mean, I'm talking about in that little function where you're only entering 9.
Oh, you mean 9 factorial? Or,
No, the second one you put in
Yep.
there. You only entered 9 one time,
I did 9, yeah.
but you did 9 and 9.
Yeah.
Okay.
You do 9 and.
I didn't see you enter it twice.
Okay, yeah, let me show you two again. Okay, so 9, math, go all the way over to prob,
Ah, okay, I see. now.
select NPR, hit enter,
So
and
the
then
first
type in
number,
9 again. Right,
first number you're entering
Is the
N,
N.
and then
Correct.
you enter the R.
right. So basically it's N permutation R in the calculator. Okay, does that make more sense now, guys? Okay, either way you guys want to do it, I don't care. That's how it operates. Okay. So for the second question we have here, how many ways can the word be arranged, create new words, if the first letter must be E and the last letter must be R? Okay, so we still have 9 letters that we're working with, right guys? 5, 6, 7, 8, 9. How many ways do we pick the first letter? 1, because it says it has to be an E. What about the last letter?
Same.
1 as
One.
well. Remember the trick, guys? You fill in what you know first, and then you fill in the rest. And what's going to be in the middle, guys?
7, 6.
7, 6, 5, 4, 3, 2, 1. Or, in other words, that's going to be 7 factorial, right? 7 fact is 50, 40. Is that correct?
Yes.
Thank you. What if we wanted to use permutations? What's a way that we might set it up just utilizing permutations? P what?
9 and 2.
Not 9 and 2, unfortunately. Good try.
7
and
and
7, right? Because we have 7, with the 2 are fixed, right? We throw them away. As soon as we know that we picked the E, we picked the R, they're out of the equations. They're already done for us. So we have 7 letters that we're picking from, and we want all 7 of them, okay? In your guys' calculator, I bet you if you type permutation 7, 7, you're going to get 50, 40 as well.
Why is it 7, 7 again? Can you
Okay.
explain it again? I'm just,
Notice what we said, but we have to pick E and we have to pick R, right? Those 2 letters go away completely.
Right.
9 minus 2 is 7.
okay,
So now we have 7 letters and we want all 7 of them. That's how we get 7, 7.
Okay,
Okay.
I'm just trying to picture what the N and the R, what they both represent, that's just,
N is gonna be the total number we're picking, so that means we only have 7.
right,
And R is how many we're actually picking out of those 7.
okay.
Okay? In this case, we need all 7 letters. Okay? We didn't say that we're only picking 5 or something like that. Okay? Other questions, guys? Okay. For the third one, how many different 5-letter words can be created from ownership? Okay, so once again, we could do the space method. So 1, 2, 3, 4, 5. If you guys were doing the space method, what would you guys fill in there?
9's on all.
9, 6, 8, 7.
Or would you didn't say, you're saying that no repetition. Earlier you stated you didn't say that.
Well, no,
Ownership.
but because these are words and you only can pick from ownership, right? We're rearranging those letters. Okay, so consider how many different 5-letter words can be created, assuming no repetition, if we're just picking those letters from that, okay? If we were picking, if it was repetition, it would just be 99999, okay? Does that make sense, guys, when we're doing this? Like if we're picking from a word, once you pick the letter, it's completely done. You can't repick it, okay? What's another way if you guys were using permutations? How could you set that up?
So that's 9.
9, 5. Good.
9, 5.
So there's 9 letters that we start with. We are picking 5 of those numbers. Right? It doesn't matter which way you guys put this in your calculator. I'll just do the permutation method, and then somebody can verify this maybe. So we would do 9, math, probability, permutation 5. And I got 15120. Did anybody do 98765 or 96785? Or maybe nobody did anything with
Yeah, I
that.
did.
Okay.
15,
15120.
Yeah.
Okay. Nice. Either way we do it. And like I said, guys, I don't care which way you guys do it. I just want to make sure that you know one of 2 different ways to be able to arrive at the answer. Okay. And then for the last one that we had, it says how many 6-letter words can be created if the first letter must be an O. Okay? So we pick the O, we throw it away. There's nothing we do with that O. Okay? We have 6 letters. If the first letter is an O, that means there's 1 there. So then what would the rest of that be if we were using like the fill in the blank method?
8, 7, 6, 5.
Yeah, 8, 7, 6, 5, 4. Now, if I was to ask you guys to set up a permutation method for that, excuse me, what would the permutation that you guys think be for this one?
6,
Not 6, 9, good try. 8, 5, right guys? We took one of the letters, we threw it away already, the O is
You
gone.
need to
So-
throw the slot away.
right, and you throw the slot away as well, right? Because that letter is fixed and it's picked, okay? So, this would say that there are 8 letters we're picking from, and of those 8, we only need 5 slots, because the first slot's been picked, okay? Remember the other one that we did up here? We had 7, 7. We picked 2 of them, so those 2 are gone, and there's only 7 letters left to pick from for 7 spaces. Okay. Does that make sense to everybody, guys? Any questions about that? You guys could easily go in your calculator and figure that out. Did anybody do that already? And if so, would they get? 6720. Thank you, thank you. Okay. So everybody feel comfortable saying I can at least do it one of the 2 ways. I can either use the fill in the blank method or I can use the permutation method. Okay? Generally, what's going to happen is if these letters start getting much longer, the fill in the blank method becomes much more tedious, right guys? The permutation method is the way you want to go. But for right now, since we're only dealing with 9 letters, then we're okay. We'll see later that we don't want to do that forever. All right. So, one of the last problems I want to work on today is one of the classic jury problems. Okay. So yeah, everybody's favorite problem. I'm just taking a look at what we still have here. So suppose for some reason we have a jury and we're picking from a pool of 8 men and 9 women. Okay. So several different questions I want to ask you guys. Okay. Some of which we'll get to today, some of which we won't. Okay. How many 5-man juries can we create? How many 5 women juries can we create? How many 9-person juries can we create? 4 men and 5 women. Okay, so let's just do those first 3 today, and then Monday next week what we'll do is we'll do the other 3. Okay, so let me ask you guys first, before we even try to tackle this problem, okay? What do you guys think? Is this a combination or a permutation problem? This is a combination problem. How come?
Because it doesn't matter.
Yeah, they're basically indistinguishable, right? It just says women, okay? It doesn't give them names, it doesn't give them faces or anything like that. It just says men and women, okay? So if you can't distinguish between one element to the next, that's going to be a combination. If you can distinguish, that's a permutation, okay?
Even though you can distinguish between men and women, you're saying there's not an individual.
Correct, right. You can group the men and women, and we will see that that does come into play when we start throwing person juries together, okay? But for right now, it just doesn't matter. Okay, so for letter A, now this is where the space method doesn't work anymore, okay? So, it says how many 5-man juries can we create? Okay, how many men do we have total?
9,
8,
80, sorry.
and we want 5 of those, right? So the way this would work is that we have 8 combination 5, okay? And again, that's just because we can't tell the difference from one man to the next man to the next man, okay? This is where we want to use our calculator. In fact, we have to use our calculator to make this convenient, okay? So, to be able to put this in your calculator, you use the exact same method, except instead of NPR, you use NCR. So 8 math, probability, NCR, and then this time instead of anything else, I'm going to put 5 in there. I got 56. Hopefully somebody else got the same thing. Okay, good. So this just is equal to 56.
And this is that formula where you end up with 8 factorial over 5 factorial times 8 minus.
Correct, right. If you wanted to do this by hand, because you have nothing better to do with your mind.
So
You
you
would
can
set-
understand how.
No, that's okay, I understand. Yeah, if you wanted to do it like this, that's fine too, okay? I don't have any problem with you guys doing it by hand if you want to use the formula, okay? I'm just guessing that it just becomes tedious and inconvenient at some point to keep using